Permutations and combinations. Permutations are arrangements of a group of objects in a definite order. For example, I've got two numbers here, 1 and 6. There's two permutations of that. They can be 1, 6, or 6, 1. Two different orders. So same numbers, but two different orders. I had a set of 3 letters, A, B, C. There are 6 possible permutations, ABC, ACB, BAC, BCA, CAB, CBA. The best way to look on this is more like we have combination locks. You can't put any 3 numbers in there. They have to be in a certain order. And truthfully, they should be called permutation locks, not combination locks. Permutation, by definition, is an arrangement of objects in a definite order. We need to be concerned not only of what's selected, but also the arrangement of it. The formula basically is P stands for permutation, with N is the number of items in the set, and R is the number of items we want. For example, we have permutation from the alphabet. We can pick three letters. There are N would equal 26 because there's 26 letters in the English alphabet. And then R would be, let's say we want to pick 3. It would be 3. How many 3-letter words, with or without meaning, can be formed out of letters in the word swing when repetition is not allowed? In other words, you can only use each letter twice. And once, excuse me. Here's my formula. Remember, when we have the explanation point, that's a factorial. So n factorial means every number below it times the highest number times the number below it all the way to 1. If we have 5 letters in the word swing, but we only select 3, the permutation for this is 5 factorial over 5 minus 3 factorial. And that's all within parentheses here in this denominator. Remember, 5 factorial is the same as 5 times 4 times 3 times 2 times 1, which is 120. 2 factorial is 2 times 1, which is 2. 120 divided by 2 is 60. So there's 60 combinations we can make of the 5 letters in the word swing in any order. I mean, for every possible permutation within unique order that doesn't repeat itself with 3 letters. Here's another example. We are scientists trying to discover the key word for a financial account. The financial consists of only 10 lowercase letters. In other words, 10 characters from among the set A through Z. And no character can be repeated. How many different unique arrangements are there? As I said, we go from A through Z. That's 26 letters. So my N is 26. My R is, we can only pick N. So my N is 26 factorial. My N minus R is 26 minus 10 factorial, which is 16 factorial. Now, I don't know why I did 120 over 2 there, but when I multiply 26 times 25 times 24, and we need the calculator, all the way to 26 all down to 1, divided by 16 times 15 times 14, all the way down to 1, we get, let's see, that is million, billion, we get 19 trillion, 275 billion, 223 million, 968,000 combinations. If we could pick any 10 letters from the alphabet out of 26, we'll only pick 10 that don't repeat. Now let's go with some permutations here of how we look at with different designations. Here is one. This P, we have subscripts over here with a 4. That is always the N, the number possible. We're selecting from the set, and then the number we want right here. That's our R right there. So that'd be 4 factorial over 4 minus 2 factorial. That which was 12. 4 times 3 times 2 times 1 is 24. 2 times 1 is 2. 24 divided by 2 is 12. P6P3, which is there are 6 items total. We want 3 to be selected. So it's 6 factorial over 6 minus 3 factorial, which we go through, this is 120. And then 6 minus 5 factorial. That is, let me erase some of this here. So we got 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, over 1 factorial. And 6 factorial is 720. Now, I didn't show you here before, I'm putting a 5 in front of it. So I multiply the 5 by this equation. 5 times 720 is 3600. Now, combination is similar to permutation, but the order doesn't matter. In other words, where I had, ABC, and we go back, we had ABC, ACB, and BAC, BCA, and then we had CAB, I apologize for my writing here, CBA. There are 6 different permutations of that. But when we do a combination, it doesn't matter if it's A, B, or C. It's the 3 unique components. And that is 1. So I may have 6 permutations with A, B, and C, but I only have 1 combination, whether A is first, B is first, C is first. It doesn't matter. B in the middle, B in the middle, C in the middle. It's just 1 combination. And when we look at this, the equation is pretty similar, except you notice I have n factorial, just like n minus r factorial, but there's an r factorial also in the denominator. Let's see, we have a bag of marbles, and it's combination with 5 total, and we're pick 3. How many different ways can we get marbles out of the bag? And they could be all different colors. So I'm looking at this. My n is 5. 5 factorial is 120. We've done before. And then we want 3 possible combinations. So it's 3 factorial times 5 minus 3, which is 2 factorial. And that's 3 times 2 times 1, which is 6. And times 2 times 1, which is 2, and that's 12. 120 minus 12 is 10. So there's 10 possible combinations of pulling 3 marbles out when there's 5 in the bag total. And these get pretty big. I've got combinations with 22 for N. 20 would be my R. And you can see I've set this up here. 22 my N, 20 R, and 22 minus 20, which is 2. And we end up getting 31. It was 7, 11, and 8. Very similar to permutation, except I've got that second R factorial out here. And each one of these here. And that usually you have less combinations than you are permutations. Here's 17 and 10. And that's a pretty big number here, 19,448, 17 in the total set. And that's 17 factorial, and then I pull out 10, so it's 10 factorial or 10 minus 10 factorial, which is 10 factorial, 7 factorial. And I end up getting 19,448. Similar to permutations, we do have some nomenclature designates. And notice when we have this is the same. It's 4C2 is 4 total number of items set, 2 the number of items we want grouped. Here's 6C3, 6 items set, we're going to pull out 3. And it's the same as we've done before. 6C, if we want to, and look at this, minus 6 plus 19C5, well, that's 19 factorial over 5 factorial times 19 minus 5 is 14 factorial. And I got to pull that 6 in. Once I figure this number out, this combination equation is 11,628. And then we're minus 6 plus that. So it's 11 minus 11 plus 11,628, which is 11,622. And as we've done before in statistics and probability, we can figure out the combination. So you see this right here. And I want to point out here, let's suppose we have how many people like Facebook? What's the possibilities? And I could have 0 people liking Facebook, 1 person's out of a group of 6, all the way to 6 people. Here's my equation. Instead that X the same as the R. Doesn't matter what order it is. But when I look at this in the end, what I'm looking at here is how many possibilities there are. And when I get my combination, my percentage combination, all these will add up to 1 or 100%. Here's another example done before. And this, I really changed this because Google News no longer exists. But they want to know, they surveyed 4 adults, and what are all the possibilities of people reading Google News? We found that 70% like Google News. We selected, we used 4 of them to see what the probability is. And I'm using my combination equation. 0 people like it, 1 people like it, 2 people like it, 3 people like it, 4 people like it. And I base it on a percentage out of it, using past history. Use my combination equation, and again, I get, based on 70% of people liking it, these are the final answers for what's the likelihood of someone liking it using combinations. And these will add up to 1 or 100%. That's how we use probability with combinations permutations in the real world. Finally, when I look at this, we can look at, what I want to keep in mind is the same data from before. We can ask the questions, how many exactly, out of these four likelihood successes, how many is likely having 2 successes? Right here, 11.95. I have at least 2. Keep in mind that is 11.95 plus 0.01629.0008. I add all those up, that's at least 2. That includes 2 or 3 or 4. And less than 2 would equal 0 success or 1 success. That's less than 2, 1 or 0 successes.